very unique and isolated in Japanese islands for many years. So that's what I explained in 5 years ago. Yeah, the finding is very interesting, but mitochondrial DNA is just one local. So phylogenetic tree and divergent kinase might contain large error. So maybe this mitochondrial DNA tree is not entirely correct. And also, many mitochondrial DNA studies have been carried out for dog domestication using many samples from dogs and wolves in the world. But the place of dog domestication is still unclear because dogs and wolves are clustered together in the mitochondrial DNA. So this tree is the same as previous ones. So this is gray big cluster. And if I put dog samples to this trees, so this blue one is showing dogs. So in this big clade, dogs are included in many ways. So they don't form different clusters. So yeah, so actually the mitochondrial DNA it shows sort of dogs and wolves are not separate groups, but it's mixed group. But it must be separated, so the mitochondrial DNA cannot have the ability to resolve the dog stage domestication. And recently, in the last 10 years, several genomic studies on dogs and wolves were carried out in many different places of the world. Yeah, most of them are from Europe, but some from US. But I will explain you later that the origin of dogs is still unclear. So, because many genomic studies shows something like this. So if we construct phylogenetic tree, this North American wolves come to this place, but Eurasian wolves and dogs form one cluster. So that means dogs must be domesticated from Eurasian wolves. That is clear. But this is the example from the studies. Trees, dogs form this cluster, and this is also from many different places like Russian, Spain, Italian, India, Mongolian, and Tibetan. And this is also from North America, but basically it is the same. Dogs and Eurasian wolves form one cluster, and North American wolves are out. And this is also another genomic studies. So this is Eurasian wolf, this is dog, and they form two clusters. But the problem is we want to have this type of phylogenetic trees. So if some roots are clustered together with dogs, maybe this is the population that this specimen comes from is the domestication area. And probably this could be Asia, it could be Siberia or it is, but if some group species form this cluster, we just say that those are domesticated in place. But unfortunately, up to now, we didn't find any unique group population forming one cluster with dogs. But recent our study may have found the one. Actually, dogs and Japanese wolves form a single cluster. And the other Eurasian roots are outside of this single cluster. This is based on genomics. So, yeah, very simple answer from the three is that the dogs were domesticated in Japan from Japanese wolves. But nobody believes that dogs are domesticated in small island of Japan. So what's happened is probably dogs are domesticated somewhere in Asia, some East Asia or Southeast Asia. But the original population become extinct or have not been found, but only the original one, part of the original population colonized to Japanese groups, colonized to Japan and become Japanese groups. So that is the reason why Japanese dogs form a single cluster. So we believe that Area X, that is the place that dogs, worldwide dogs are domesticated, might be somewhere in East or Southeast Asia, but the population, full population has been extinct. And so at the moment, we don't know exactly where it is. Some of the researchers from America appear to believe that wolves are domesticated in North Siberia. And we think that is also possible. If dogs are domesticated in Siberia, maybe some of the population come to Japanese islands. And then become Japanese foods. That is possible. But yeah, this example shows that the study of Japanese foods might provide a good answer to the origin of domestic dogs. So maybe you think that, that is the study of Japanese foods, so that is not related to Indonesian people, but the studies on Japanese foods can provide some information or insights on the local domestication. So maybe some studies on Indonesian domestic animals like chicken or cattle. I believe you have many unique breeds of domestic animals. Maybe a genomic study of such breeds can provide an insight domestication history of important animals like cattle, chickens, pigs. So I have to speed up my talk. So the second part of my talk is the evolution of taste receptor genes, so I will speed up the stories. And I don't explain the details, but humans feel taste using taste buds on the tongue, and there are taste cells, and in the taste cells there is a taste receptors, and we feel the taste using that one. And researchers clarified that we have 5 basic tastes, that is sweet, umami, salty, and bitter, and sour, and that is common for vertebrates. Even fish have the same 5 basic tastes. And animals use these tastes to get, so using sweet taste, for example, they can energy, material containing energy from sugar, and using umami taste, they look for protein, and using salty taste, they look for mineral. So this taste is very useful and important to get important food. And bitter taste and sour taste is also important to avoid poisonous things or putrefied things. So this kind of taste is very important because it has influence on the survival of the animal. And so the sense of taste differs between species depending on their living habitat and the feeding ecology. So if species live in different places and eat different foods, maybe their taste sense of taste differ. So by the way, I just explained umami taste because some of you don't know about umami taste, but that is basically a taste of Ajinomoto or glutamate. And yeah, that is Japanese researchers have identified about hundreds of years ago. And European people don't know or don't recognize this umami taste. So umami is coming from Japanese language. So since European people don't have the don't have the same taste, they have umami taste, but they didn't recognize the umami taste separately. So even in English, this taste is called umami taste. But anyway, that is the taste of amino acid or proteins. And we have 5 different basic tastes. That means 5 different taste receptors. So sweet, for example, sweet taste receptors affect sugar, and the sugar is sent to the brain, and we feel, oh, that is sweet, or that is sweet. And for the sense of taste, there are variations between individuals, even in humans. For example, PTC, that is kind of a chemical people usually feel very taste. And one of the studies showed that about 75% people feel this PTC very bitter, but about 25% don't feel bitter. And this difference is based on the difference in bitter taste receptor genes, actually. And in humans, three different mutations. So this is entire sequence of the one of the beta phase genes has to 38, and only three mutations causes the taster to change taster to no taster. So maybe how you have this mutation, and basically this difference in gene actually DNA sequences is result in difference in protein or taste receptor. So if this figure explains the taster, then in the case of non-taster, there are three mutations, so taste receptor has changed, and sugar sugars are not accepted to the taste receptors, so they don't feel bitter. So this difference in cause difference in taste. And probably some of you already knows that basically the sweet receptor of cats, we saw cats about 20 minutes ago, but they lost its function because there are several mutations in sweet receptor genes. And that is very true to not only domestic cats, but in the cat family every day. But people, why people think about why they lost sweet taste, because the reason is clear, because the cat families are obligated carnivore. They only eat meat and they don't need sugar from food. So they don't matter if they lose the sense of taste. And there are several other species lacking sweet taste, sweet taste. For example, sea lions or some of the otters actually the sequence are broken and they lost sense of sweet taste. And it's okay because they almost exclusively eat fish or other invertebrates. And sweet taste genes of vampire but are also broken, and it's okay for them because they are specialized in blood feeding. And another large group that lost sweet taste is birds. Actually, the genomic studies showed that all birds don't have sweet receptors in them. Not the sequence has been modified by mutation, but they don't have sweet receptor genes. So this is sort of genomic schematic figure from the website. Humans have sweet taste receptor genes here, but here the bird must have taste receptor genes, but it's lacking from here. So it must be between the two genes, but so this explains why most birds don't eat sweet taste materials. I have to speed up. But why it does lack the sweet taste receptors? Probably you can guess, because the ancestor of most birds is carnivorous dinosaurs, and dinosaurs didn't need sweet sugar. So probably the three receptors have broken in dinosaur, and that's why bird doesn't have three-state genes. But yeah, probably, some of birds eating nectars or fruits like hummingbird like this. So I have to speak a lot of details about the mechanism, but we put the taste receptor gene sequences into cultivated cells, and we study the function of the taste receptors of hummingbird. And then, for example, this is taste receptors for mice, and the umami taste receptor of mice respond to amino acids, but not to sugars. So this is the comparison between species, mouse, chicken, and swift. But this is respond to amino acids, but not sugar. But hummingbird taste receptor respond to sugar, but not amino acids. That means the hummingbird use umami taste receptor to sense the sugar. So that means hummingbirds doesn't have sweet taste receptors, but they change the function of umami taste receptors, and they can accept sugars in that. And this is the recent study by our group, published about 2 years ago. That is songbird. So maybe you know that the bird of the order Pateroides or Paterines, representing more than half of the bird, and songbirds contain more than 5,000 species, so they are very successful group. And actually, we found that not only hummingbird, but the sweet umami taste receptors of songbird also change, and they accept sugars, and they don't accept umami amino acids. And actually, this shows the very big phylogenetic trees of birds, and this is songbird, and this red line shows the proportion of nectar eating in their diet. So actually, you see many nectar eating in Pacific, and we have figured out that actually the ancestor of the Pacific or hummingbirds, some mutation or genetic shift has occurred, and yeah, so in this place, still amino acid sensed, but after that, sugar is accepted by umami taste receptor. We constructed the ancestral form of the umami taste gene. So maybe this is the key innovation of the radiation of the songbird or Pacific. So maybe I should skip this part of the talk. These are about case studies of the among the old world monkeys, and manufactured here, and this shows leaf eater, Asian leaf eater, and African leaf eaters. And we studied beta phase, and leaf contains a lot of beta substance, and we have the out the outset of the repeater, the function of the beta test receptor has lost. So they can eat a lot of leaves, but macaques are mainly eating on fruits. Unfortunately, I just eat these things. But I want to summarize the value, the taste detector means. So because central taste is very important for animal species because it directly relates to what they eat and what they don't eat. And so, as you know, the body and behavior of animals changes according to the environment. That is called adaptive evolution. And also, and different in DNA sequences of taste receptors reflect the history of evolution of each species. So if we study the difference in DNA sequences of taste receptor genes, we can clarify the history of adaptive evolution of species. And yeah, I want to add that to clarify the evolutionary histories, it's very important to study biology it provides the basis of the study of the evolutionary history. Yeah, I'm sorry, I have to skip the final part of the talk, but thank you very much for your attention.
Thank you. Thank you very much, Sensei. Banyak hal ini rasanya yang kita dapat pelajari ya. Rupanya nggak setiap kita ini tahu dengan manusia. 3% nggak tahu. Tapi dengan mata semua tahu terbalik. Melihat. Pernah merasakan orang manis kita tidak supaya penuh. Itu ada yang dulu datang prinsip saya kan. Yes. Now out of this our student, they understand the sweetness. Since they say 24%. You know, understand that sweetness. This in the group. Kemudian tadi apa ya? Bagaimana Sensei melihat itu dari ternyata makan itu sangat tergantung kan dengan jamu. Kenapa ada belum yang apalagi sementara kucing-kucingan kan tidak suka dengan manis. Jadi kucing ya agama ya itu salah jadi banyak yang saya tanya sekarang ya tapi pada akhirnya kita bertanya ya bisa manis bulan masih sering itu nanti silakan dulu bertanya silakan.
Thank you very much. I really curious about polygen dog and wolf is so wolf related, and so because domestic dog is so wide from part of the small one and the bulldog is big one, and is it the same group compared to the wolf? I did the first question, and the second question is why in the nature of habitat the wolf or the species look like similar, not so wide compared to the domestic one. So how, because the wolf is supposed to be similar, right, from the wolf other part, it's really can recognize the wolf. It's look like similar, even the different species of wolf, but dog it is single species, but it's so varied. And why in the natural habitat species is tend to same species compared to the domestic one? That's my second question. Thank you very much.
Pertanyaannya kenapa algae itu ada besar sekali dan kecil? Ya,
Yeah.
kemudian ada peneliti alam di alam kita udah pembudayaan jadi banyak cara-cara itu ada Amerika atau berapa
Well, if we should look at the diversity of genomes, those contain very, very small diversity actually. And group contains a lot of variation. But why some of those are very, very small and some of those very, very big? Because it's because of artificial selection by humans. So very, very strong pressures picking up very, very big individuals and select and form one leaf and select one small individual to form small leaf. And that makes a big, huge variation in body type in those. That means the overall diversity of genome is quite small in dogs, but the variation in genes related to the size is quite big. It's because of human selectivity. And on the other hand, for wolves, their general diversity is quite large, but the selection pressures for body size or behavior is quite strong to keep the body size consistent and same. So that's why so the almost in different environments are basically in the same form. Although there are some variation in the body size. Not about this a bit bigger, one, but that is my answer.
Yeah, but I think it's not a size matter, but figure and face, it's so varied in number.
Yeah, so that same applies to many traits. So like shape of the ears or shape of the tails or everything humans select what they prefer, what they want to have. That causes the variation of body shape types in those.
So it's mean that if we make an operate or we mix all of them and become wolf again.
Yes.
Yeah, I can say that like that.
Yeah.
And the second one, why in the nature of habitat it only like a single shape of the species, not so many. I'm thinking about the variation from the real like like the next question is related that is there any species in two different part has a different shape but equally same species because maybe in the past there is a separation then one like a for example, in this part of the region is bulldog, in this part of the region is this kind of maybe another species. But I think in the natural habitat is still like same. There is no such kind of variation.
Yeah, that is an interesting question. So it's a bit difficult answer for correct answer is a bit difficult because it's depends on the definition of species. So how we can say, oh, this and this is different species. So people usually say if the shape is different, maybe we call this these are two different species. But if we study the genomes or any other thing, many things in genomes, sometimes we found that, actually, they looks like just one. So, or maybe in opposite case, it's more popular. The shape is quite same in entire place, different places, or or in the whole country. But if we study, we carried out population genetic studies and we study many genetic markers, people can find that all these are and these are different populations, and sometimes it is called cryptic species. So that is, of course, it depends on the efficiency of species.
Thank you very much.
Since it cannot be answered.
So I want to know the point of the point of your question. Can we? So you say why the form and or say the size are similar or
Set as because the square of the element parts. The square of the shape. Different color. Actually, the similar space. Square. To pair by the square.
Yellow.
Oke. Jadi tadi sedikit. Jadi katanya sensei yang berjalan itu artificial selection. Manusia juga ini karena tidak ada yang pertama manusia kayaknya sama semua. Oke, kalau ada yang lain, benar. More about dogs. Dogs.
Yeah.
The popular movie. The dogs in video. Is it original or indigenous in Japan? Indigenous. Sorry, you meant Hachiko in the trailer? Yes. The type of dog in the Hachiko. Pernah melihat film Hachiko? Dan kalian harus belajar nonton ya. Ada sedikit pertanyaan. Nah, dog from Japan.
Indigenous type dog.
Indigenous.
Hachiko.
Sama Hachiko.
Yes.
Your genetic tree, Hachiko include in your research or no?
So the Hachiko is actually from the breed called Akita dogs, and Akita dog is also included in the study. And actually, the history of Japanese dog breeds is quite different from European breeds. So European breeds are forms, as I told you, with the strong artificial selection. Worked on dogs as well, and some dog breeds are specialized for hunting. Some are going together with sheep, for example, and some are pet dogs. And so European dogs are very, very specialized, but in Japanese dogs, not forms like that, but it's quite general and it's just moving around the house and it's but person come we are just barking and something like that. So in general, Japanese dog breeds are quite generalized and keep original forms. Probably Indonesian village dog is similar to the Japanese dog.
And second question.
It's okay. Start and fall.
Are there the research about plant in your lab? What? Tumbuhan.
Plan.
Yeah, again, in the first part of the talk, I said if we extract DNA from plants, it must be same, but unfortunately, we are specialized for animals, so nobody's working on plants.
Faculty maybe.
Apparently, there are some laboratories on forestry or forestry ecology, and some of them are doing molecular research and
Okay.
Ada berapa? About class 1 and 2 gene for sweet based in animal. More animal don't have it. Actually, what about we do engineering animal gene? For some animals don't have that gene. If it is great, it is that can disturb statement because that is about evolution or no? If we do that research, it can be disturbing that evolution because the gene is also we call evolution. If we do great, that can be or not.
So you mean the modifying means, yeah, So that is also very difficult question to answer, and so now technically, we can change the genes as we want. For example, several catalysts, for example, cattle have formed a big area to handle, and recent papers show that genome editing technology can eliminate those hormones from cattle, and that's safe. And technically it's possible, but the later study showed that that modification also caused some changes in the genome. So so that could cause some problems even for humans because human consumes meat or milk. Some of the researchers say that it's possible and okay, although the genomic technology speed up the change, but the process is similar to the natural mutation. So, some recent genomic technology different from previous genomic engineering because the previous one is taking some genetic sequences from other species to another species, but the recent one modifies the genes as what we want to change. So and if my personal opinion is asked, I'm still very careful, and don't want to promote such genomic engineering technology. Of course, research is important and we should do a lot of research to make backgrounds, but for animals, still we have to be careful to make it commercially available modified animals.
Gimana? Oke? Itu sekian mahasiswa. Bisa disensir.
Thank you for the very nice talk. Actually, I met Matsumura for the first time in 1990. Oh, so it was in the conference, the French University, and you can get it from the same university, and you get from the same lab. The university is and I have been present so actually, while all animals require carbohydrate and sugar, but while some animals they have a deep low So this is the first question. And the second question is, can we just make a clear, separate something like distinguish between the herbivore and carnivore when we are looking at the test plot? Because the herbivore, they need, of course, they need more carbohydrate. But for the carnivore, they require more protein. So can we have a clear pass here difference between the technique between the two classes? Okay, and then the last question. I'm thinking that can we also break when we are talking about break load or activity plot. So and the kids likes more sugar. And the elder people and the old people, they don't like much candy anymore, right? So either something related to the bracket of the gas sector or just something related with the metabolic environment. Did you get my question?
Yeah.
Yeah, thank you.
Yeah, all the questions are quite interesting. And the firstly, all the animals are basically needs carbohydrates. And yeah, so in general, the switch taste receptor is quite useful and it's important. It must be, but yeah, evolution is very strange. It sometimes work or cause unexpected things. For example, so in cats, they don't take you basically carbohydrates from here. Accordingly, for example, plant, but somehow they manage to produce carbohydrate from meat. So they are called obligate carnivores. So they can survive only be eating on meat. I don't know why, but just such specialization is sometimes quite beneficial for the species. So that happens. So if such a specialization happens, then they can lose the sense of taste, sweet taste, sense of sweet taste. So I think the such specialization occurs fast, and after that they can lose the sweet taste. And for the second question, it's simple answer is I can say that there are big difference between dogs and cats. Or cat family and the animals related to, or they are animals, and we simply believe all they are similar. But the taste and food habit is quite different. Cats are usually carnivores, so they can survive only on meat. But those and other species related to dogs, like fox or wolves or the family or dog family, they sometimes eat carbohydrate stuff and sometimes food. So they still keep the sweet. And that is also relating to your question that it's very difficult to distinguish carnivores from sense of taste. So some carnivore species have sweet taste, and some carnivore lost sense of taste. And final question is related to developmental changes. That is quite interesting. But you know, genomic sequence had no changes during the development. So basically, their sense of taste or their ability of sensing taste has not changed. What happened is probably one possibility is the change in the expression. So maybe sweet taste receptors are expressed more in the child. So that's why they need sweet stuff, and that is also beneficial for kids who eat a lot of sweet things for the development or to keep metabolism. And also, it is also related to other kind of things or factors related to their behavior. So maybe the sense of taste doesn't differ between kids and adults, but somehow adults can behave differently. But kids, they are more active for getting sweet things. But the point is the sense of taste itself probably the same between kids and adults.
Jadi kita semua Paris sebenarnya ada maka ada proses formula memang buatnya itu berubah. Consider to all sometimes different in the S. And it's sweetness. Okay. Somebody need to much or sweet. The other will be vegetable. Like that. Yes. Can differ from the kid to the adult. Ada penanya? Ada yang bertanya? Silakan. Ya.
Thank you for the and my question is, scientists said that phylogeny of books might contain large error because it's just using one purpose. My question is, I want to make it sure. Did it mean the research using only just one gene or one gene in mitochondria? And what is the solution Is it better to using more robust to compare the hydrogen networks or is there any solution?
Yeah, so my answer is, yeah, even in one locus or one locus, but the study using mitochondrial DNA is still very, very important. So yeah, that is very important first steps to understand biology. Yeah. And yeah, so yeah, I have to be careful about that. But then why we might have a lot of error in constructing other trees using mitochondrial DNA. In the case of dogs and wolves, is the separation of dogs and is quite different. That's why that there might be a huge error and there might be a big overlap between the two groups. So yeah, usually a species phylogenetic is construct this the speciation of the much older than the separation between dogs and wolves. So in that case, yeah, in most cases, mitochondrial DNA can give very good answer for the history of the evolution. That is one thing. But of course, it's better if we add the results from other genes, I mean, increasing the number of studying genes. So of course, useful and better. That is my base.
Dia boleh satu gen anda mitokondria itu tidak ikut perkawinan. Maksudnya kepala sperma saja, mitokondria ibu. Jadi kalau berubah ya, memang kursi. Tidak ada efek kepada perkawinan. Nah, yang sudah belajar sudah akan jauhnya belum berubah. Saya
Banyak Pak, banyak ada lagi ya.
sila bertanya. Jadi ini
Our studies showed that the available samples, Japanese food are the most closely related to dogs and not other samples, for example, from here, like Mongol or like from India. But actually, we don't have samples, for example, from Indonesia, because you don't have foods in Indonesia or Thailand. But maybe many times ago, there might be extinct foods here in Southeast Asia or some part of East Asia. So that's why yeah, I expect maybe the playtex is Southeast Asia, or I wrote East Asia, but I basically meant that as part of East Asia, like China, from other part of China.
Jadi ada yang batang. Silakan. Jadi ke depannya kan anak
Or is my
ini dia bagus. Kok jadi ada ini? Tanda dulu. Enggak, dengar.
My name is Amanda. I am a issues that in their ability to sing. Maybe because of they can type with us, the song is getting better or moving. It is more related to the beat.
Sorry, can you sorry.
Sini aja dulu. Sama pas. Calir, calir.
My question is there any relationship from songbird that can test sweetness with their ability to sing? Maybe because of they can test sweetness, the song is getting better or tonally. Or this is more related to the fit of that songbird in. Is it clear, sir? Thank you, sir.
Yeah. I have never think about that possibilities, and yeah. At the moment, I don't see any direct connection between sensing sweetness and singing. But usually, yeah, there's really unexpected things in the world or in the nature. So, for example, swimming is quite energy-consuming activities only, and probably getting sweet stuff and lot of energy can help the evolution of singing, for example. And actually, yeah, if I simply say that the order of the passive forms contain the singing parts. So I must say it was studying active relationships. At the moment, there are no finding about the relationship, but that is quite interesting possibility. I must.
Terima kasih pertanyaannya dapat ide sebenarnya. Dikatakan beri ayam bulan tidak dapat. Kemudian yang ada upaya bertingkat itu sebenarnya energi saja. Jadi memberikan buat telur ayam apa ya madu supaya berkokok bertingkat supaya energinya bisa itu mestinya. Itu bukan berarti lebih bagus kok. Sedang. Kalau dari jauh banyak. Sangat baik.
If there's something you need to develop on that station, or maybe you need to find something in the or something relative to for that adaptation. Maybe that's my question. I'm sorry, I didn't look up and get the.
Okay, so maybe my question is, you just said that you expect to us that the votes is just the area X is maybe the Southeast Asia or maybe in the East Asia. I just need to know that there's any something that you need to developing your research on basic on that hesitation, sir. Or maybe there's something genetic relation that you need to improve in that research to get that information, sir, to get the point of that hesitation about what you're researching. Maybe that's my question, sir. Please.
Yeah. I'm not so sure whether that I got your point completely, but so basically we need more the information from Southeast Asia or southern part of East Asia. So it could be from living individuals, I mean, even those, or maybe if we find small population of wolves in that area, hidden population in this area, that could be helpful. Also, if we find some ancient bones of wolves or dogs from this area, and if we can extract the information from the material, that could solve the question, yeah, in the future.
Ya, tadi usul Pak Eri konkretkan batas. Gimana? Oke.
Yeah.
Okay, sincere, thank you very much for your class that to increase our knowledge, our knowledge about the equation and phylogenetic. I hope this is not the last time you come in. I do this many times. Coming again for the next special classes. Okay. Untuk sekarang, sedikit terima kasih banyak untuk yang sudah datang. Mungkin terakhir kan baru tanya lah. Since maybe time for join you in your laboratory. Yeah. Some students need to join your research laboratory because so if some of you are interested in coming to Japan directly, I'm actually doing some material here or yeah. Yes, thank you very much. And I'm also very impressed that there are many questions from students. Usually, if I give a lecture in Japan, yeah, I have very few questions. So sometimes I feel very disappointed. But yeah, today I am very impressed by the attitude of the students. Thank you very much. Thank you. Terima kasih juga Pak Zaki yang sampaikan. Saya satu pertanyaan ini dokter kita Tanuki. Tanuki, ya Tanuki. No, Tanuki itu isi nomor. Terima kasih Pak Eri kedatangannya ke kita. Assalamualaikum warahmatullahi wabarakatuh.
Ini ada ya, kalau Anda lihat di websitenya namanya sandwich program. Jadi di di Gifu ini ada sandwich program 6 bulan, tapi untuk S2 ya. Jadi kalau Anda masuk S2 6 bulan di Jepang, dibiayai selama 6 bulan ya. Kita UNAN dengan Gifu sudah ada kerjasama. Jadi
Kalau yang ambil nanti S2 ya Januari program namanya 2023 itu sudah habis tahun depan lagi ya. Jadi kita bisa berhubungan dengan CC untuk mencari siapa pembimbingnya ya. Tadi sudah bicara jadi namanya teori program ya di Gifu dengan si lokal namanya ada kerjasama itu ada untuk S2 juga ada peneliti ASEAN Bridge program ya ASEAN Bridge program jadi itu dibiayai S2-nya jadi ada S1 S2 sekarang saudara ada orang sudah mendaftar bulan ini ada tes wawancara orang jadi online ya jadi nggak harus jadi dosen dulu hanya mendaftar online aja jadi di Gifu jadi nanti hubungi saya ini ada email oke nanti bagi yang berminat ya jadi bukan hanya bukan hanya animal science ya juga plant science juga ada di buka di website itu bisa ada yang berminat bahasa Inggris jadi S2-nya bahasa Inggris ya S2-nya bahasa Inggris terima kasih
Ya, demikian saja siapa yang mau
ya orang ibu
Ya. Mendampingi. Ya, tahun itu tadi. Tahun itu baik. Banyak.